We'll go through Additional Mathematics Form 4 textbook question for Chapter 6 Linear Law Mastery Practice. If you enjoyed this video, can you like, subscribe, and do leave us a comment. So let's get straight to the first question. We're supposed to express the following non-linear equation in linear form, in the form of y equals mx plus c. So here we have to convert to linear form, and in order to convert to linear form, I think the key thing is to identify what is your big Y, big M, big X, and C. And big Y means variable in your y-axis, big X means variable in your x-axis, M is your gradient, and C is your y-intercept. So the thing is, your C here must not have any variable X or Y. So if you look at the first equation, part A, you have both terms with X. So you have two options. Either you divide by X to get your C to be 3, or you multiply by x squared to make C to be 4. So I will show you both options. So first option, I will maybe just multiply by x squared first. So you get x squared y equals to 3. X multiplied by x squared, you get x cubed. 4 over x squared times x squared, you get 4. So this will be your big Y. This is your gradient M. This is your big X, right? And this is your C. Okay, so when you plot y versus x, I mean x squared y versus x cubed, you will get a straight line, right? Okay, second one, we're going to multiply, instead of multiply, we're going to divide by x. Okay, I'll show you method 2, if you like to call this method 2. When you divide by x, you will get y over x. Okay, the 3 here, when you divide by x, you just get 3. And the 4 over x squared, when you divide by x, you get 4 over x cubed. So what happened is, we can rearrange it and put 4 bracket 1 over x cubed and leave the 3 outside. So this is your big Y, this is your gradient, this is your big X, and this is your C. Yeah, so by plotting y over x versus 1 over x cubed, I will get a linear form as well. Yeah. Okay, part B now. You have x cubed and x squared. So to change the linear form, you must convert one of them to C. Remember, C is the one without any x, so maybe we can divide everybody by x squared. Because I can see that between x cubed and x squared, maybe just divide by x squared, it will be easier. Y over x squared is now P. This will be a single x, and this will be cubed. So this is your big Y now, this is your gradient, and your big X, and your C. So by plotting y over x squared versus x, you get a linear form. Now you can also divide by x cubed, but I think it's not necessary. This is method 2 if you want. Yeah, even textbooks show you both answers. Yeah, both method 1, method 2. When you divide x cubed, what happens is you get y over x cubed, but this term involving x squared will give x cubed will be just b, and the one with x squared here will be left with q of x. So it's better for us to separate this to show clearly which one is your gradient, which one is your y-intercept, and so on. So this y equals mx plus c, right? Is it necessary to draw this arrow to label y equals mx plus c? It's actually not now, but I just want to show you clearly which one is your gradient, which is your y-intercept, and so on. Okay, for C, again, I have x over x and x, so we can maybe times x, you get xy equals to p plus q over p x squared. And when you rearrange this, put q over p first, x squared, and put the p last, right? So this will be your big Y, this is your gradient, this is your big X, and this is your C. So by plotting xy versus x squared, you will get a straight line. So another way is by taking this method 2, instead of multiplying with x, we divide by x. So I get y over x, this is p over x squared, and this is q over p. Now what we can do is we separate this p and 1 over x squared, keep the q over p at the back. This is your big Y, this is your gradient, this is your x, and your C. Okay, so it's just another option. Instead of multiplying x, we can also divide by x. Alright, okay, let's move on to the next one. Okay, so the next one is involving logarithm. Now, how do you know when it involves logarithm? Okay, the term or the type of equation involving logarithm, they have a power x, or can be x to the power something, right? That we cannot separate them and change y equals mx plus c. Like for example, this is the first one. You can't even bring this up to y equals mx plus c unless we introduce logarithm. So I'm going to do here log base 10. Now actually you can use any other bases, but the commonly used base is base 10 because we can calculate base 10 from calculator. Right, now you can also use base e, since you've learned in Form 4 Chapter 4 natural logarithm ln. Yeah, you can also use ln, but somehow for the textbook the question for linear law, mostly they are using log base 10 instead of log base e. Okay, so we're going to break this up to log 10b plus log 10k power root x. Remember, in logarithm times we break it up, becomes a plus. And if you have a power, we can transfer the power root x in front, log 10k at the back. Alright, and next I would put the log 10k first. Yeah, sorry, I'll put log 10k first because this is my gradient. Root x is my big X now. Log 10p is my y-intercept. Yeah, this is your big Y, this is your gradient, this is your x, and this is your c. Okay. Alright, so I'm going to do part E over here. This is part D. Okay, part E over here. Okay, so part E is rather similar to part E. We introduce log on both sides of the equation, log 10p k power x minus 1. It's rather similar because it's also multiplication and it's also to the power of x. So your x is the power now. So when you break this up, this will be log 10k to the power of x minus 1. And that x minus 1 we can transfer in front, right? And from here, I'll just rearrange, put log 10k first, put x minus 1 later, and log 10b last. So therefore this is your big Y now, this is your gradient now, this is your big X now, and this is your C. Okay, so D and E, they're quite similar. Let's move on to part F. Okay, part F, we introduce log on both sides of the equation. There's a k with the power x squared over p. I think the clear difference is, the big difference is this is minus a divide. When you break it up, it's a minus here. So you break up to minus log base 10p, and the power x squared you can bring in front just like the first earlier two, right? And remember to rearrange it. Let's put log 10k in front, x squared at the back. So this is your big Y now, this is your gradient, this is your x, and this is your c. Okay, all right, let's move on. Okay, the next question is question number 2. Okay, variable x and y, they are related by this equation, y equals bx squared plus qx. Yeah, such that p and q are constant. Diagram shows line of best fit obtained plotting y over x against x. So they already told us that what we need to do to convert to linear form, that is to take this equation and divide by x. Okay, so when you divide by x, you can see you get these 2 points. So we can find 2 things from the graph. Okay, we can find gradient and y-intercept. But first of all, the question asks us to convert to linear form. So let's just take this equation and divide by x. Y over x is now bx plus q. So this is your big Y now, this is your gradient, this is your big X, and your C. So by plotting y of x versus x, you get a straight line. Okay? So this is your linear form. B, find the value of p and q. Now actually there are 2 ways to do it. Number 1, you can actually find the gradient y-intercept and then just compare gradient y-intercept. Number 2, we can take this equation, form the equation straight line from here, and rewrite in the original equation and then compare. However, because the question already asks us to convert to linear form, it's actually easier to find the gradient and y-intercept from the graph and compare with the gradient and y-intercept that you got after converting it to linear form. Okay, let's find the gradient from the graph. Yeah, we use y2 minus y1 x2 minus x1, this will be 2 over 8, which is negative 1 over 4. Now, there is a missing part in your textbook actually, because you probably never really learned this formula. Yeah, in the past in Kssm syllabus, we always use this equation, y minus y1 m x minus x1 to form equation straight line. It is slightly easier compared to the y equals mx plus c method that you learn in your Form 3 syllabus, right? However, since you haven't learned this method, so I will just use y equals mx plus c, right? Okay, if you know your gradient and you know a point on the line, we can find your y-intercept. So I'm going to use this 0.15. We can even use 9.3. Okay, I use 1.5. Your big Y is now 5. Your gradient is negative 1 over 4. Your big X is now 1, and you're finding C. So be very careful. Now, why I use big Y and big X? Because I don't want you guys to think that your Y, for example, some people think, oh, this is your Y over X. So they go and put this as Y, this as X. Like, for example, they think Y is 3, X is 9. No, the Y over X value is now 3. This is your Y over X value. Is the one that you've converted to linear form. So it's wrong to think you should take 3 divided by 9 to get your Y over X. It's not, because your Y over X by itself is already 3. So that's why it's I would say I would advise students to use big Y, big X when you sub inside, right? So that you don't get confused. This big Y is based on Y over X and not Y alone. So let's bring this over and find C here. My C is 5 plus 1 over 4, which is 21 over 4. You can leave it as 5 1 over 4. Now let's compare your gradient from the graph and the gradient from the equation. You can see quite clearly from my equation, my P is my gradient. From my graph, my gradient is negative 1 over 4. So in conclusion, P is negative 1 over 4. Or we can write this as negative 0.25. And your y-intercept from the graph is that we have calculated is 21 over 4. My y-intercept from the equation here is just Q. So Q is 21 over 4, or you can write positive 5.25. Okay, sorry, let me rewrite nicely. 5.25. Okay, so I hope this is not too difficult, right? Okay, moving on. Next question. All right, this one also quite similar, but it involves logarithm, right? How do I know? I look at the axis here. Can you see it's log, right? And this is x squared. So the question also mentioned that the straight line is obtained by plotting log 10 y against x squared. So here I will just use back the same method I used for number 2. That is, I convert this to linear form. Introduce log 10 on both sides of the equation. So this will be log 10 y equals to log 10 pq power x squared over 4. All right, number 2, when you break this up, is log 10 p plus log 10 q power x squared over 4. Now, what we can do next is to transfer the power x squared over 4 down, and you get log 10q, yeah, next to it. Again, we need to rearrange it. For me, I will put log 10q with a 1 over 4 first, put x squared later, and log 10p last, so that you can see clearly this is your big Y, this is your gradient, this is your big X, and this is your C. So by comparing your gradient, you can find the value Q. By comparing your y-intercept, you can find the value C. But you have to go back to the equation and find your gradient and y-intercept. Gradient will be what? y2 minus y1, x2 minus x1. So you should get 5 minus 4 is 1, 6 minus 4 is 2, 1 over 2. And for y-intercept, again, I use y equals to mx plus c. Now you can sub any point I use for 4. Yeah? So your y is 4, your gradient is half, your x is 4, find c. So this is 4 equals 2 plus c, c is just 2. Okay, I've got gradient, I've got my y-intercept. Let's just compare. Okay, now let's compare the gradient from the equation. I got 1 over 4 log 10q, and the gradient from the graph is 1 over 2. So log 10q, take the 4 times over, 4 times half is just 2. And q we can change from logarithm form to index form. You can write q equals 10 power 2. If you're unsure, you can even use your calculator. You can press shift log, then you can see 10 power 2 on your calculator, press equals, your q is 100. If you compare your y-intercept, my log 10p is now 2. From my graph, my y-intercept is 2. From my equation, my y-intercept is log 10p. Again, we change from logarithm form to index form, is 10 power 2. Yeah, the 10 here, power 2, which is 100. Okay, yeah, it's pretty standard. I would say this is a very standard, typical exam question. Yeah. Okay, next question, number 4. All right. Okay, this question is a bit unique. It's a bit different. As in, most of the time, they will give you unknown in the equation. Can you see? Most of the time they give unknown, but this question, there's no unknown in the equation. In fact, there's only variable x and y, right? So and then they put an unknown in your coordinates. So the way in which we do it will be different. Now I know some people, they go and find the gradient from the graph. They say, oh, I use y2 minus y1, k minus 3 over 2 minus h is my gradient. And then if, oh, I'm going to find my y-intercept, y equals to mx plus c. Then I sub in the point, your y is k, your m is k minus 3, 2 minus h, my x is now 2, plus c, I find my c is k minus 2 times of k minus 3 over 2 minus h. And then my equation is y equals to mk minus 3 over 2 minus h plus my c, k minus 2 of k minus 3 over 2 minus h. It's just like, oh my god, so complicated, am I right? So you wouldn't want to do this, right? And we have to try a different approach, right? So what I will do is, I will first convert this to linear form, right? I'll take this equation and divide everybody by x. Now, how do I know that I have to divide by x then? The question says, when you draw y over x versus x. So by dividing with x, I will get 5 minus 3x, right? Divide everybody by x. Okay, I will rearrange the equation to negative 3x plus 5. Now you can see clearly that this is your big Y, this is your gradient, this is your x, this is your c. Correct. So big Y is now minus 3x plus 5. Now notice, by replacing your big Y with your x, y over x with big Y, and your small x here with big X, I've got the linear form. And what do you think is the easiest way to solve h and k? Well, we can take this coordinate and we sub inside, right? Your big Y is now k, your big X is now 2, your k is now negative 6 plus 5, negative 1. Alright, and if you want to find h, you sub h and 3. Your big Y is 3, your big X is h, so 3h is now 5. I bring this over, 5 minus 3 is 2, h is 2 over 3. Okay. So you should try different approach, okay? If first approach cannot work, you know, it's quite complicated. If you use the same method like before, use different approach. Okay, now let's move on. Question number 5. Okay, this question I find is very interesting because again, it's a little bit different than the standard method that you always see. Okay, however, I want to say this, that the question, there is a mistake, slight mistake in the question. It's not supposed to be log base 10. It's supposed to be log base 2. So yeah, if you check the answer at the back, it's based on log base 2, not log base 10. If you use log base 10, your answer will be in lots of decimal, right? It will be very complex. Right, supposed to be log base 2. Okay, now first they say you have a straight line y equals to ab power x, okay? And you're supposed to sketch a straight line, yeah, when you plot log 10 log base 2 y against x, okay? And they ask you to plot mark the coordinate. So before you sketch, right, we know initially you're using x versus y, but now you're using x versus log base 2 y. So you can see the original coordinate is supposed to be 1 and 4. Now it's 1 and log base 2 4, which is going to give us, maybe I write 2 here. Yeah, log base 2 4 is 2, right? You know, right? Okay, the second one, when your x is 3, your y is 32, so it's log base to 32. 32 is 2 power 5. This is going to give us 5, right? Okay, now to plot this, I'm going to draw log base to y versus x. Okay, and I have 2 points. This is just a sketch, don't have to plot accurately, so I will say maybe I put here, this will be 1 and 2, maybe I put here 3 and 5. Yeah, so this will be your first point P. Maybe I call it prime because it's a new value after you introduce log. Okay, so it's 1 2. This is point Q, which is 3 5. So join together, there you go, you got a straight line. Okay, now then they say based on the graph in A, find the value of A and B. Now maybe I have to convert this to linear form first. Yeah, your original function is y equals ab power x, so I'm going to use log base 2, y equals log base 2 ab power x. So when you break it up, it's log 2a plus log base 2b with the power x. You want to bring the power in front, yeah, and you want to rearrange this. Okay, and this will be your big y, this is your gradient, this is your big x, and your c. Now once you arrive to this point, then whatever you are solving and the way you're solving is identical to the question earlier, like question number 3. Yeah? So we need to find gradient and y-intercept from the graph. Okay, let's see. Yeah? Find the gradient, 5 minus 2 over 3 minus 1, which is 3 over 2. Right. Find the y-intercept, y equals mx plus c. My y-intercept, I sub in 1 and 2. You can use 3, 5. I use 1, 2. My y is 2. My gradient is 3 over 2. My x is 1. My c is 2 minus 3 over 2, 1 over 2. Okay, so now what I want to do is I want to find or compare my gradient from the equation, which is log base 2b, with the gradient from the graph. My graph is 3 over 2, so b is 2 power 3 over 2. Now you can use your calculator and type here. Yeah, type in your calculator. What do you get? I think you get 2.828, right? Now, by the way, you can also write 2 set 2 if you want. Yeah, 2 set 2 is the same. Now, for c, log base 2a. From your equation, your y-intercept c is log base 2a. Your graph, your y-intercept is half, so a is 2 power half. You can write square root 1.414 or just root 2. Okay, either way, whether you're in leave decimal, sub form also can. Okay, yeah, I like this question, it's quite interesting. Okay, let's move on to next question. Okay, in this question, we're supposed to work backwards, form equation straight line, and then express y in terms of x. Okay, so normally we will give you an equation to start with, so we have to like convert the non-linear to linear form, but this time the equation is not given. But they really mentioned that it has gradient of 8. Yeah, it has gradient of 8 and it passes through this point. So we know number 1, gradient is 8. If I use y equals to mx plus c, I can sub in 2 and 19. My y is 19, my m is 8, my x is 2. I want to find my c. My c is 19 minus 16, c is 3. So my big Y is now m, which is 8, x plus 3. Okay, what's your big Y? Your big Y is now x squared y. Can you see when x squared y is plotted against x? So this is x squared y. Okay. Sorry, I haven't done part A yet, not complete yet. So your big X is just X. I just need to make Y as a subject. So maybe I will just divide by x squared, 8x plus 3 over x squared. Yeah, so I've got Y in terms of X. Okay, next, part B, find the value of Y when X is 9.4. Okay, this is also not difficult. just use your calculator. Sub inside 9.4 plus 3 divide 9.4 square. Type in your calculator. You should get 0.8850. I'll leave it correct to for significant figure. Okay, that's number 6. Okay, moving on. Number 7. Okay, number 7, we have to draw a graph. Alright. Okay, to draw this graph, right, we supposed to plot m against x, m against v, right? That means this is m is the mass on the y-axis, v is your volume on the x-axis. Okay, so I will use 2 cm to 1 unit on both axes, so it's quite small. Yeah, that's why I put a small graph paper here, right? Okay, let's draw. So this is my axis. Okay, this is v, this is my y-axis. My line is not very straight. This is m. Alright, so this will be 0, 1, 2 and 3, 1, 2, 3. Okay, I don't have to draw more than that. You can see on your horizontal axis 0.5. The first point is 0.5 and 0.35. Okay, I can just zoom in. 0.3. Oops. Okay, so 0.5, 0.3. Now the accuracy of your graph is up to half of the smallest box. You can't read anything smaller than that, so 0.35 will be here, right? Okay, second one is 1 and 0.84. 0.84 is, you can't read 0.84, but you can read 0.85, so 0.85 is in between, right, over here. Next one is 1.5, 1.23, 1.5, 1.23. Now again, can't read 1.23, but we can read 1.25. The closest is 1.25 over here. Okay, next one is 1.6, 2 and 1.6. 1.6 is over here. All right, a bit bigger. After that, we have 2.5 and 2, 2.5 and 2, and lastly 3 and 2.7, 2.37. Okay, we can read 2.35, 2.35. Yeah, it's in between. Okay, so from here we need to draw the line of best fit. Okay, it looks like it's going to pass through 0, but not 0, not exactly at 0. The way I see it, it's not exactly at 0. So okay, I'm going to use a ruler here, right, to draw my line of best fit. Wait. It is not exactly at 0. Okay, I need to move this a little bit to the right. Oops, it's too small. Here. Where's my ruler? Yeah, not exactly at 0. Move it up a little bit. You can see. Yeah, it's a bit hard to draw. You can see you must pass through as many points as possible, but sometimes you can't have all the points on the line. You can see the first point is not on the line of best fit, definitely. First point is out. Second point is a bit higher as well. Yeah, so I think it looks something like this. Okay, okay, a bit off as well. Okay, I think this is a bit off, sorry, because yeah, I must move a little bit up, a little bit higher. Okay. The ruler is taking like 0.1 mm. Yeah, this will be better, but not perfect. Yeah. Okay, you can see this 2 point is a little bit, the first point is a bit lower, second point a bit higher, third point a bit higher, and the last 3 points is basically on the line of best fit. Yeah, and this is not exactly 0, very close to 0, but it's not. Okay, all right, so I think that is about it, right? Yeah, that's all. So okay, not a problem. Okay, let's move on to the next one. Okay, the next one, my line, I need to draw a line of best fit as well. Okay, but first I need to plot the points. Okay, so you can see here, for this graph, we are plotting 2 cm to 5 unit for on y, 2 cm to 10 unit on x. Okay, so let's put all the label everything first. Okay, so the first one will be 2 cm to 10. So this is 0, 2, 4, okay, sorry, 0, 10, 10, 20, 30, 40, 50, 60. The largest is 60. Let me draw this straight line. Okay, this is bad, sorry. One more time. Okay, line is not very good. This is your horizontal axis is x, your vertical axis, okay, let me label first. This is 5, 10, 15, 20, 25, 30, 35. The highest I should go is up to 35. Okay, so let's draw all the way up. Okay, not too bad. So if this is your y. Okay, now the next thing is I'm going to plot the points. The first point is 10, 16.5. Okay, I need to zoom in. Sorry, I can't see. I like to zoom in, yeah, so that I can see clearly that 16.5 should be, this is 16.5 is 3 boxes, because this one big box is 10 small boxes, and one big box is 5 unit, one small box is 0.5 unit, so this will be 16.5 will be 3 small boxes above 15. Alright, the next one is 20 and 20, 20, 20, oh, this is easy. Next one is 30 and 23.5, 23.5. I will count 1.5 below 25, which is here. Next one will be 40 and 27.5. Okay, 27.5 is just in between 25 and 30. So it will be right here. Next one, 50 and 31.5, 31.5, 3 small boxes, 60 and 35 will be right here. Okay, so there you go. Now the next thing is to draw my line of best fit. Okay, I'm going to draw from here. I can see that it looks like it's going to pass through around 12, right? So let's adjust a little bit. Maybe I move this up a bit, move this out a little bit, hard to see. Okay, so okay, where is it's 12.5. Yeah, it's around 12.5. 12 or 12.5. I think the textbook answer, if I'm not wrong, they give 12.5 as the answer. So yeah, you can. I think it's around there, right in between. Okay, so yeah, I can take 12.5 as answer. So it looks like this. This is my line of best fit. Yeah, not too bad. Almost all the point, but maybe I can improvise a bit. You can see that 2 points are slightly above, right? 2 points are slightly above. So I think I can improvise a little bit. I need to slant it a little bit more, right? Because it's a bit too low. The gradient is supposed to be higher. How about now? Better, slightly better. Oh, I think it's still about the same. Sorry, try to be perfect. Sometimes you can't be perfect, right? Okay, I just move it a bit higher. Okay, I think this is better now. Right? Okay, so now this is about 12.5. Okay, and to find gradient, right, because you need to find the equation of straight line, right? So to represent the line of best fit, yeah, to find the equation of straight line representing the line of best fit, I would suggest that you use 5 boxes. I will use 5 boxes because any number divided by 5 is a nice number. As in, I would pick, let's say, this point here. Oops, this point on my y-axis. You can use any other pointer. I will use 0, 12.5, and I pick. I count 5 boxes horizontally. I will pick this 50, and it looks like 31.5 still. Still the same as a point on the table. Now, understand this. Avoid using a point on the table rather than use a point on the graph. Sometimes they are different, right? Sometimes the point, as you can see, is slightly higher than the line of best fit. So, okay, I'm going to use this. Now, let's calculate our gradient, okay? My gradient will be 31.5 minus 12.5 divide 50 minus 0. Now, why do I like to use 5? Because any number divided by 5 is a nice number. So here I got 0.38, yeah? My gradient is 0.38. So to form my equation, this straight line for part B, I just write over here. I know my big Y is mx plus c. Okay, in this case, don't have to use big Y because it's already a small y. Your big Y is the same as small y. Okay, my gradient is 0.38. My y-intercept is 12.5. Okay, so this is my answer. Okay, just so you know, because your textbook answer is slightly different. Your textbook gave us textbook answer is 0.375x plus 12.5. Okay, what I've done is I use a regression calculator. You can actually use your 570EX class quiz or any other calculator actually has this regression calculator. A regression calculator, when you key in the point, it will give us exactly what's the gradient of y-intercept. Actually, the most accurate answer from what I've got from the calculator, your gradient is 0.3886. But this is kind of impossible to get sometimes, right? Depending on how many points you get from the graph. Okay, which points you use. And my y-intercept is supposed to be 11.9. So if you get 12.5 or 12, that's fine. Yeah. If your gradient is 0.38, I think it's fine. In fact, 375 is not too far off as well. Right. So this is my answer. Yep. Textbook answer is slightly different, but I think that's fine. Okay. Let's move on. Next one also involving drawing graph. Okay. So question number 9. Okay. You're plotting T versus T. The big T is temperature, small t is your time. So, okay, let's start with the horizontal. So we put 0 on your horizontal axis here. So this is 0, 2, 4, 6, 8, 10. Vertical axis 10, 20, 30, and 40. So let's draw this is your horizontal, small t, in second, big T is your vertical axis. So temperature in degrees Celsius. Okay, now zoom in and show you the points. So the first point is 2 and 29. It's a very small graph, very hard to draw. 29 is here. Next one is 4 and 40. Now this point is a bit off. Next is 5 and 31. Sorry, 6 and 31, 8 and 32.5. Now 32.1 is a bit hard to draw. We can only draw 32, and last one is 33. Yeah, so you can see every 2 it will increase by 1. So I can more or less know that your y-intercept will be at 28 because every 2 increase by 1, right? So let's use a ruler and measure. And this, the second point is out, is definitely out. Okay, so it looks something like this. Okay, there you go, that's my line of best fit, right? Could be better. I think I need to tilt it a bit. keep the angle a little bit smaller, right? Maybe at 6 or 5. Okay, let's see, how about this? Okay, this is better. Okay, come, let's go back to your the first part. I've already plotted graph and then drawn a line of best fit. Second one, I need to mark the point which is recorded wrongly. So the point recorded wrongly should be this, okay? And then find the correct value. Okay, maybe I use a different color just to illustrate it. The correct value should be on here. You can see it is at 30. So I will write the correct value will be 30. Yeah, you can write 30 degrees Celsius. Now, what is the initial temperature? It looks like 28 degrees Celsius, right? After 9 seconds, you can see every 1 second it actually increases by every 2 seconds increases by 1. So every half a second, 1 second increase by half. So at 9, it will look like in between 31 and 32 and 33. So it's 32.5. 32.5. If you can't see it, I'll just show you here. It's just a bit hard to draw. Yeah, I use dotted line here. At 9, if you move across, oops, it is around here, 31.5, 32.5. Yeah, 32.5, between 32 and 33. Okay, so very hard to see, it's very small. And last one, find the time taken to reach a temperature of 30.5. 30.5 will be here, in between 30 and 31. So you can see it's again the middle here, right? So just move it down. Okay. So I've got 5, right? This is 5. So just write the time is 5 seconds. All right. Okay, let's continue with the, I think it's the last one, the last graph. Oh, 2 more graphs, sorry. Okay. Now for this question, you're supposed to, number 1, plot log 10y against x. Okay, so you may have to recalculate your table values. So now I don't have space to do everything, so I'm just going to put my log 10y here. I think I will have, yeah, log 10y here, so I'm going to write it down. The first one will be, if you take logarithm of 2.51, you get 0.40. Log 3.24, you get 0.51. Log 4.37, you get 0.64. Next one, 0.76, 0.89, and lastly 1.0. Yeah, you can write 1.00 if you want. Okay, so this is 0.89. Let me write nicely. Yeah, 0.89. Okay, we're supposed to plot x versus log y. Yeah, log y versus x. So my horizontal axis, the scale is 2 cm to 1 unit. So let's just move this up. 2 cm to 1 unit means this will be 1, 2, 3, 4, 5, 6, 7, 8. Maximum is 9. Wow, I really don't have a lot of space here. So yeah, you can draw a, okay, I think don't need to use a ruler, just freehand. Okay, this is log, this is just x. Your horizontal is just x. Okay, your vertical, we have to start with 0, 1, 0 0.1, 0 0.2, 0.3, 0.4, 0.5, 0.6. Keep going all the way until 1.7, 0.8, 0.9, 1.0, largest 1.0. This is log base 10y. Okay, I'm going to draw a straight line here. Again, a bit hard to draw. So I start from bottom all the way to the top. Okay, now next let's plot the point. The first point will be 1 and 0.4. So 0.4 over here. Next one is 0.51, 2, 3 and 0.51. Okay, 0.51 over here. 4.5 and 0.764. Okay, I need to move this up a bit. 0.64. 4.5 will be here, 0.64. Next is 6 and 0.76. 6 and 0.76. Okay, next 7.5 and 0.89 and 9 and 1. Okay, right. Okay, only the first one looks a bit off, 0.4. Oh, because it's not 1, sorry, it's not 1, it's 1.5, sorry, I think I've seen wrongly. It's 1.5, so we should mark here. Okay, alright, so let's draw a line best fit. Use a ruler. It looks like at 0.27, around there, 0.27. Okay, almost all the point line on the line best fit, right? Right? Yeah, I can't zoom any closer, that's the thing. If I closer, yes, ruler 27, slightly. Okay, let's draw. Okay, look at that. It's quite nice, yeah. Okay, maybe one or 2 points a bit off. The second last one is a bit off, but it's okay. Yeah. Okay. Now the next thing is we need to look at two things. We need to find. They say draw the line best fit, right? And done already. Okay, let's look at the next page. If you're supposed to find two things. Okay, you're supposed to find three things actually. Find x, s, and t. St, the value of x when y is 4. Okay, you may have to switch from one page to another. You know that to find s and t, you need to start from your equation y equals to st power x. Introduce log base 10 on both sides of the equation. Break this up, log 10s plus log 10t, and the power x you can transfer in front. Alright, so this is t log 10, this log 10t. Yeah? I just switch the s at the back. Maybe I write one extra step for you. I'm going to write log 10t in front. This is x, this is log 10s. So this is now your big Y, this is now your gradient, and your x and your c. Now we can find gradient and y-intercept from the graph. Okay, so you go back to the page before. Okay, find the gradient y-intercept. Okay, my y-intercept looks like at this point. So 0 and 0.27. Now I like to count 5 boxes. Like I said, 5 is always a nice number. When any number divided by 5 is a nice number. Okay, so this is around 0.635. Can you see? Oops. Now mine gets slightly different answer. That's okay if you get a slightly different answer. I think the textbook also, yeah. Textbook answer your gradient is 0.08. I look at it as though this is 675. Yeah, I like to use this point here. Let me show you this point over here. Oops. Okay. Okay, wait. Okay, sorry. This point here, 0.675. Looks like 0.675. Okay. So, yeah, this is 0. This is 5 and 0.675. Okay. All right. So let's calculate the gradient. I'm sure you're working over here. My gradient is 0.675 minus 0.27 divide 5 minus 0. Okay, 0.675 minus 0.27 divide 5, 0.081. Okay, just so you know, the answer I've got from the calculator, you can, like I said earlier in the previous question, I mentioned that you can use your calculator, the linear regression what do you call that, function, and you will get the gradient to be 0.081. This is the most accurate answer. 0.081 is the most accurate answer. And your y-intercept, the most accurate answer is 0.0274. But we can't get 274. You either get 274 or 275. So, sorry, 27 or 275. Okay, I got 27. Okay, so my gradient is this, but the textbook answer is 0.08. Okay, slightly different. Okay, just so you know. Okay, all right. So go back to that question here. So if you find your gradient from the graph to be 0.081, then we write log 10 t equals 0.081. Then use your calculator. T is 10 power 0.081. You can press shift log, or we call it the anti-log. My answer is 1.205. Now if your textbook, they got 0.08, and therefore the answer is 1.202. Okay, by the way, I think textbook give a lot of decimal. Don't need to do give such accurate answer. For significant figure is good enough. Yeah, this is my answer. This is a textbook answer, just so you know. Okay, and your y-intercept for my graph is 0.27, right? So when you take log base 10 s equals 0.27, your s is 1.862. Okay, again, textbook, they got C to be 0.28, which is still okay, I think. Log 10s is 0.28. Textbook answer is 1.9. Sorry, this is 905. Okay, okay. So yeah, this is my answer. This is textbook answer. Like I said, the most accurate is 0.274. 274 is the most accurate from the calculator. Okay, I still got one more to go, guys. The value of x when y is 4. Now, when your y is 4, okay, this is Roman 1, Roman 2 done already, 1 and 2. Roman 3, when your y is 4, what is your log base 10 y? Log base 10 y is 0.660. So we have to go back to your graph. Where is 0.6? Yeah, because the question says from the graph, 0.6 is over here. Okay, yeah, my graph is a little bit different. 0.6. Yeah, perhaps my graph should be a little bit higher. Yeah, you can see it's not 4. It's close to 4, but it's not 4. It's 405. Yeah, it looks like 405. Okay, so if you move it downwards, it's here in between 4 and 4.1. Okay, sorry, my line is a bit off. Yeah, so it looks like it's 4.005. Okay, 4.05. Can you see? 4.05. Okay, so go back to this page. So from the graph, my x is 4.05. Okay, textbook answer is 4.0, just 4. Okay, either way. All right, now next question. I think this is the last one. Yeah, now we're supposed to find draw a graph of xy versus x. Okay, I need xy but don't have space, so I'm going to write xy over here. I hope can squeeze in here, right? I need to recalculate my xy. You're supposed to plot xy versus x. So xy is 1 times 5, which is 5, 2 times 3.5, which is 7, 3 times 3.1, 9.3, 10.8, 13, and 15. Okay, 2 cm to 1 unit on x-axis, 2 cm to 2 unit on xy axis. So 0, 1, 2, 3, 4, 5, 6, and this is my horizontal axis. Okay, x. This is 2, 4, 6, 8, 10, 12, 14, all the way up until 16. This is my xy axis. So let's just draw a line all the way up. Okay. All right. Now with that, we start plotting the points. So the first point is 1 and 5. 1 and 5. So over here. Second point is 2 and 7. 3 and 9.3. Okay, you can't read 9.3. Oh, you can. 9.3 is in between. In between 9.2. Now 9 is over here. 9.2 will be here. 9.4 will be here. In between 9.2 and 9.4. Okay. The next one is 10.8. 4 small boxes. The next one will be 13. And move down a bit. After 13 is 15. Okay, so my graph is okay. Now let's plot the line of best fit. So I look at it. I think your best fit should be here. This point is a bit off. There's one point that 9.3 is a bit off. Yeah. The rest are well within the 9.3 is a bit off. And also the point after that. So it looks like this. Okay. So one point is a bit off, one point is a bit low. Well, can I do better? I think I can do better. Maybe a bit lower here. Let's see. Yeah, I think this is maybe not. Okay, this is the best for now, right? One point a bit higher, one point a bit lower. I think that's fine. Yeah. Okay, so next I can see this looks like 3 point. It's between 3 and 3.1 and 3.2. So between 3 and 3.2. So I'll take 3.1. Okay. So yeah, or some people say 3. I think textbook gives 3. Yeah, textbook gives 3. Maybe I'll just take 3 lah. I think it's closer to 3 than to 3.1. So I'll take 3 as the answer. I think, but if you use a calculator, it's 3.06. If you use a calculator, you key in the linear regression function, you get 3. Okay, all right, it's okay. And let's find our gradient. We need to find the gradient either way. So my gradient, I will pick 5 boxes, and it looks like this point is exactly on the line of best fit. So it's 5 and 13. This point is 0 and 3. My gradient will be 13 minus 3 over 5 minus 0, which is a very nice answer too. My y-intercept is just 3. All right, go back. I need to find the value of P and Q. So I would show you the working here. All right, my graph start from here. I need to convert this to linear form. So 2y equals to q over x plus p. I multiply everybody by x. I divide by 2 at the same time. So when I multiply by x and divide by 2, this is q over 2. This will be p over 2x. So xy is p over 2x plus q over 2. This is your big Y, this is your gradient, this is your y-intercept. You see, your big X is the same as X. Okay, so I'm going to squeeze in here my gradient. If I compare from my equation with the graph, my gradient is 2. So P over 2 is 2, P is just 4. And if you compare my y-intercept is q over 2. From the graph is 3, equation is 2, q is just 6. Also, right, so this is 4, this is 6. Also find the value of y when x is 3.5. Okay, this one you have to find from the graph. Okay, so when x is 3.5, you can see from here 3.5 is in between 3 and 4, right in the middle. Okay, okay, looks like it's on the line, exactly 10. Okay, so I go back to this and write from the graph when x is 3.5, yeah, x is 3.5, my y-axis xy is 10, so we need to substitute 3.5 inside here and take 10 divided by 3.5. Yeah, 10 divided by 3.5. My y, if you round off, is 2.871. Yeah, 2.871. Okay, finally, calculate the value of x when y is 50. Okay, they say calculate. Calculate, we can use your calculator and sub inside in your equation here. We already know that your y, your 2y, okay, maybe I use this equation here. Right, my 2y is now q. Q is 6 over x. My p is 4. So my y is 3 over x plus 2. Take, I think we can sub in directly since I want to find x, right? I think I sub in from here. Let's take y equals to 50. So 2 times 50 equals 6 over x plus 4. 2 times 50 is 100. 100 minus 4 is 96. 6 divided by 96. Very small value. 6 divided 96. 1 over 25. 1 over 16. 0.0625. Yeah, so you can write this as 0.0625. Okay, that's all for this mastery practice. Okay, just so you know, we have a collection of books. Yeah. Notes, tutorial, topical practice, past year question, drill practice. If you're interested, you can get in touch with us or visit our, find us, Pusat Tuition Teliti at Shopee, and you can order the books if you want, yeah, for additional practice. All right. Okay, thank you for watching this video. I'll see you in the next video.